everyone for coming after lunch. So today I'm going to talk about detecting credential compromise in AWS, but also going to then pivot after we talk about how to detect that compromise and talk about how we can actually prevent it from the get-go. So if you were in the talk yesterday that I was joined with Travis McPeak, I introduced some of these concepts about how you could do some sort of API protection, protect your metadata service. And so today we're actually going to deep dive into those topics and get a little more detail in what sources we're using for detecting the compromise and how we took that and then decided, well, that's not good enough. Let's pivot and try to prevent that. But for those that don't know, I'm Will Bengtson. I am a senior security engineer on the cloud infrastructure security team at Netflix. Our team's mission is to protect the infrastructure security of Netflix throughout all of our accounts, our environments within AWS mainly. And my team's main goal is protecting the ultimate low-level piece of AWS, and that's the credential. Where everything starts is the permission, and that's where we're going to be focusing today. I want to first just start and say this is not a complex machine learning talk. I don't have these like really advanced models. I'm not a data scientist. I'm just a security person that happens to find data very interesting. We just set the mood for everyone, so I hope everyone likes it dark in here because we're going to go deep. But I've been corrected, and someone has actually told me this is machine learning because it's unsupervised. It kind of learns as you go, but you can take it, call it what you want. But today we're going to talk about how you detect compromise in AWS. So the scope of the detection piece of this talk is detecting compromised AWS instance credentials. And so if you're not familiar, instance credentials in AWS are short-lived keys. They're anywhere from 1 to 6 hours lived. They are issued by the service for you and rotated automatically. The security token service, STS, in AWS is what's actually providing these temporary credentials, and they're being provided based on the actual IAM role that you provide to your instance when you actually deploy. So you can use this within the EC2 world, or as well if you're just creating temporary credentials for your users within your environment, you can also use this STS service. It's there for you. I believe it's 15 minutes up to 36 hours, depending on how you actually federate into the STS service on how you can issue those. But mainly within EC2, it's 1 to 6 hours that you're going to see these credentials lived. And hopefully AWS keeps up and rotates those for you automatically. So we're going to be focusing mainly on these types of credentials around the EC2 world. But you can apply this methodology across containers or any other means that you can control how credentials are actually issued in your environment. So what's the problem? We have all these credentials moving throughout our environment. By default in AWS, when a credential is issued, it's issued and available to the world. Amazon makes it very easy for you to operate in the cloud in that everything works from everywhere. So when you craft a credential, it's valid from my machine, from your server, from other servers, wherever you want. So that's a problem that we're trying to address today, is how do we detect when a credential issued to Netflix or to Slack or any other provider running in AWS is only valid in that environment? How do you detect when it's actually being used outside? And today we're going to focus on how do you detect when it's used from the attacker's AWS account and not just an attacker's laptop from their house. So who's doing this well? I still haven't seen anything public that I know about where they're detecting this type of compromise well. Amazon GuardDuty is doing some detections, but they're doing detections of outside of AWS. And so if you think of the scope of AWS, that's rather large. As I mentioned just now, there's multiple players in the game, Netflix, Slack, many other people are actually using AWS, including the attackers. And so we wanted to actually detect outside of our environment within AWS. Knowing that AWS is very large, most companies operate there, including the attackers, we wanted to really narrow down and know when our credentials are actually being used outside of our environment. And so that's where we're trying to solve this. And why is it so hard? Well, at Netflix, it's very hard for us just due to our scale. We are very large. I don't know if we are the largest deployment still in AWS, but we have hundreds of thousands of instances at any given time in our environment. If you've ever operated in AWS, there's things called rate limits. And rate limits are essentially what AWS is using to protect their APIs so that they can service every customer. In order for us to describe our production environment in the 3 regions that we operate in, it can take us an hour to describe every server running. So if you think about trying to constantly describe those IP addresses in our environment to see are any calls being made outside of Netflix AWS, it can take very, very long to get that. And if you think of how dynamic our environment is, it's a constant change of IP address that we have to constantly be aware of to correlate back to the data that we're actually trying to figure, did a credential get used outside of our environment? And so it's very hard for us to, at any given moment, any given second, know exactly what IPs we might have had in our environment, that we might have missed something. And so I needed to try to focus this solution outside of I will never know, or with the assumption that I will never know the IP space in my cloud. So the tool that we're actually going to use today for this detection mechanism is something that AWS offers for free. It's called CloudTrail. It is now enabled by default in everyone's account in the console for 90 days, or I guess previous 90-day access. You can see every call that's been made. It's the first thing you should turn on in your account if you're operating in AWS. It's 100% free, except for the storage of the logs that they deliver to you. But it's very minimal cost, and from a security perspective, especially around the focus of this talk, it's key for this to work. So CloudTrail, for those that aren't familiar, is the audit trail within AWS. Think of it as a recording of every single API call that you make. And this is via the console, the SDKs, the command line, or any AWS service doing something on your behalf for you. As I mentioned, you can access this in the console, 90-day history by default, or you can have it delivered through CloudWatch Logs, the simple storage service, S3. If you choose to have it delivered to S3, which we'll cover in this talk, the file name will be something of this format. And you can choose to centralize all of your CloudTrail to a single bucket, and then kind of centralize your pipeline of data processing off that bucket. When you choose the S3 delivery option, the CloudTrail team will be buffering up API call audit history and delivering those 15 to 20 minutes delayed from when those calls actually happened. So one thing to note with this, at least avenue of detection today that we're going to talk about, you will have a 15 to 20 minute delay, but there are other avenues to get these calls faster. It's just when you think about the S3 delivery method, which is the sample architecture today will cover, it's a 15 to 20 minute delayed window. So if we dig a little deeper in what CloudTrail actually has and why it's useful for us, we can look here and see that one of the most important features of CloudTrail is user identity. And within user identity, you can have the type of credential that's actually making that call. In this case, it's an IAM user, but in the case that we're actually going to focus on here briefly is IAM roles. But if we dig into user identity, we have what's called an Amazon resource number, and this is the unique ID of the thing making operations or API calls in your account. And this is what we're going to track. We're going to track temporary credentials issued to these ARNs, and we're going to focus on whether or not these credentials are being used in our environment or not. And once we go through this, we're going to see a live demo that was recorded because demo gods have not been good here at AppSec Cali from what I gather. But you're going to see this live and in action in real time. So the demo that I'm going to show you today is not based on the S3 files. It's based on real-time logs via CloudWatch events, but it should hopefully not disappoint. If we dig a little more into CloudTrail, we can see what event or API call was actually called, what region did it happen in, and most importantly for this talk, the source IP of this call. And so we're going to build up this kind of history of source IPs being made and generalize whether or not a call is being made within our environment or not. So one of the common best practices for CloudTrail is that you deliver it via S3 to a bucket. Now you can still choose to operate on faster log source via CloudWatch logs or CloudWatch events, but it's generally good to have a audit log that you store for a longer period of time, be it for compliance or other reasons. And one of the best practices is if you're operating in many accounts, that you centralize the CloudTrail records to a single bucket. This helps for a lot of different logistical reasons from an orchestration of infrastructure, but if you can have all logs go into a central bucket, you can control access to those logs well. You can then kick off your pipeline for data processing from a central point, and you no longer have to worry about orchestrating the different versions of Lambdas or whatever you're trying to use to orchestrate that from outside. So at Netflix, we've chosen to centralize all of our CloudTrail via S3 to a CloudTrail bucket. And from there, we can then kick off many different pipelines to analyze those logs for anomaly detection, credential compromise detection, and so on and so forth, whatever we'd like to look at. So when I first started trying to solve this problem, I was attacking it from a very straightforward approach. And some of the problems that I talked about earlier of why it's so hard. I defined some requirements to say, I wanted to know all the IPs in my environment for all of our accounts for the last hour. So I needed to have this window of time that I was actually keeping the IP's history in our environment, mainly because I needed a history of it, knowing that I was 15 to 20 minute delayed in log delivery, but I wanted to keep some extra data around. If I could have all the IPs in my environment to the resolution that I needed, well then as I'm analyzing these CloudTrail logs, I can just look at the IP source and say, did I have this IP at this time? If the answer is yes, all is well. If the answer is no, then potential compromise. So alert if you don't have the IP, continue moving if you do. The problem was, in our environment, we're rather large. There's things called pagination with APIs in AWS, which is essentially you have so much data that you have to make several calls to actually describe that data. And once you're making several calls in a row, at our scale, you get rate limited quite a bit. And that's where the previous mention of it could take an hour to describe our production environment in 3 regions comes about. We operate in a very large account structure. Lots of calls need to happen in order for us to describe our entire environment. And it became basically impossible for me to actually assert at a given second of time what IPs I actually had and do that actual comparison that I was looking for. So while our cloud networking team was re-architecting some event-driven data structures for networking IP allocations, I went off to figure out how could I solve this? Is it possible to do it another way? And that's where I came up with this approach that we're here to discuss today. So this approach uses a leverage or an understanding of how AWS works to our advantage, which we'll discuss how credentials are actually crafted and delivered to the servers and how they're actually used. So once we have an understanding of how AWS works, we can make a strong assumption that feels reasonable, and you can decide whether you agree with me or not. And after we have that understanding and an assumption, we can then run this processing on it and then hopefully profit. And by profit, I mean we can detect potential misuse of our credentials in our environment via employees being curious, doing things that are an anti-pattern to our deployment methodologies, or perhaps even a malicious actor. And the method that I'm about to describe can be used historically as a have we ever been potentially compromised in the past, or you can start that detection mechanism today, and within 6 hours coverage, you'll have full coverage within your environment if you are centralizing CloudTrail the way that I described earlier. Now, I say 6 hours, and that's because, as I mentioned earlier, when credentials are crafted by the EC2 and STS service, they're between 1 to 6 hours long from a valid period, and so those are being rotated at least once every 6 hours. So you could start this today, and within 6 hours, have full coverage in your environment. So let's take a look at how AWS actually works. Given these services, we have our Amazon EC2 instance running on the left. We're going to interact with very different things. We have our server in the middle. So when you first launch a service in AWS, you're launching an EC2 server. The Amazon EC2 service is actually going to call out to the IAM service via the STS protocol and do an assume role. The IAM service is actually going to respond back to EC2 and give you the temporary credentials. Those credentials are available in 3 forms: an access key, a secret key, and a session token. These are then going to be passed to the metadata service, and the metadata service is an HTTP endpoint that is essentially virtually available to your server. These credentials are hosted on a certain path of that endpoint and provided to the SDKs and various different pieces of software that you might be running on your server. When your SDK needs to make calls to AWS, it's going to reach out to the metadata service to look for the credentials. It'll then cache those credentials and then use the credentials to sign API calls that will be made to the API service. When an API call is made to the service will then check the validation of the signature. IAM behind the scenes is checking the permission, and then the AWS service is actually going to decide whether or not it's going to log that call in CloudTrail. And we'll discuss why that's important here in a little bit. But the most important piece is the EC2 service is going to craft a temporary token for you and pass that to the service. One of the great benefits that we have and what we're going to use here is that when the EC2 service is crafting a session credential, a temporary token, it's passing the server instance ID in as the session name. And within Amazon, instance IDs are globally unique across all customers. And so we know that that temporary credential that's crafted is for my server and my server only. And from there, we can track that unique token and see how it's being used in our environment. So the strong assumption that we're going to use here is that first call wins. As we see these temporary credentials being crafted for the individual service, the first IP address that we see being used by this temporary credential is the one that we're going to assume is the source of truth. We're going to lock that to that IP address, and then any deviation from that IP address will be a potential compromise or a misuse of this credential. So if we were to diagram this out of a flowchart, the pink areas would actually be the path to compromise, and we'll zoom in on each one and discuss how we actually do that. So if you think we're centralizing CloudTrail via a single S3 bucket and then doing some analysis as files are being delivered, we're going to actually go through and process the CloudTrail as we receive it. In a CloudTrail file, you'll have an array of records that you'll go through. So you're going to go through the records, and we're going to look for that initial EC2 assume role call that they're crafting those first set of temporary credentials for your instance. If we have it in a session table, or we're going to ask that question, is it in the session table? If not, we're going to add it to this temporary session table that we're building, and then we're going to just continue on and go through and process more CloudTrail. And we're going to just continue forward and forward until we actually have built up every single credential in our environment. If it's not the EC2 service doing the assume role call, we're going to see if it's a call from an assumed role credential. If you remember back, the example CloudTrail record that I showed was an IAM user. In this case, we're looking for an IAM role of a type assumed role. If it's an assumed role call, that means that it's a temporary credential making an API call in our environment. And so then we're going to move on and ask, do we have record of the session credential being minted already? And this is where that 0 to 6 hours comes in. If we don't know that the credential has been minted, we just throw that record away and continue processing. Now you can choose to just, as you see a unique record, even if you haven't seen that initial mint by the EC2 service, you can choose to lock on that IP at that point. But in this implementation, we've chosen to just continue moving forward, knowing that eventually we'll see that actual EC2 instant minting that credential, and then we can continue processing from there. If you have it in the session table, we're going to check a edge case, which we'll cover in a bit. And these edge cases are whether or not it's AWS making a call on your behalf, or whether you've chosen to whitelist a specific set of IP addresses that you allow credentials to be issued or used from. Maybe you allow your developers to actually pull credentials down and use it from your VPN, but in this case, you're actually able to move credentials a little bit in your environment. If it's not AWS or within the whitelist that you might have, we're going to check the source IP. If the source IP matches, or if it has the source IP in our list, we're going to see if it matches. If it doesn't, then we're going to alert. If it does match, then we know that this credential is being issued in our environment from an area that we already know, and we're going to just continue on as normal. And so you're going to continue processing these CloudTrail records on and on and on, and only alert from a deviation. When you're making calls in AWS, it's somewhat important to understand how traffic flows. This will give you an idea of what IP addresses you might expect, as well as if you're actually going to get a public or a private IP address. So in this network diagram, we have a simple VPC, virtual private cloud in AWS, with an external and an internal subnet. If you look at the flow one, we have an instance and an external subnet making an API call to the internet. This call is going to go directly to the internet, directly to the API for Amazon, and you're going to see a public IP registered in the source IP. If we're deployed internally and you see number 2, the network flow, the internal network traffic is actually going to flow outbound via a NAT gateway. And so in this case, you're going to see the NAT gateway public IP as the source IP. And so what that means, internally deployed instances are going to share that same public IP in the table that we're actually going to build. So don't be alarmed as you're building this table that you see multiple keys being valid from the same IP address across your infrastructure. Now, one caveat to this entire thing is if you have VPC endpoints or VPC gateways, like the S3 endpoint gateway, flow 3 and 4 here, no matter which subnet you're deployed in, external or internal, if you make a call that happens to go over a private endpoint, you're going to see a private IP actually in your private or in your source IP address. So you're going to need to account for potentially seeing a public IP and a private IP for the same key. But at that point, hopefully you know what your private IP space is, and you'll be able to say, is this within my IP space or not? I debated for a long time whether to actually put what the sample architecture was for this because it just seemed very, very simple. Has anyone in the crowd ever drawn a straight line architecture? It was kind of amazing after I drew it. I was like, wow, this is actually quite simple. And it kind of leads back to this is not this complex machine learning hard problem. You can deploy this rather quickly and can be very, very effective. But here once again, we have CloudTrail being centralized to a bucket. In our case, we chose to have an SNS topic be invoked on file delivery to the bucket. This allows us to kick off multiple pipelines. You can have multiple things subscribed to that SNS topic and do multiple things on the files being delivered. In this case, in the demo that we're going to show today, we have a Lambda function going to be kicked off, and that Lambda function is going to be doing that processing and using a DynamoDB on the back end to create that session state as we see the credentials being minted and locking to the IP addresses. And we'll build one right here in a second manually. We're using Dynamo to kind of leverage what they have called the TTL feature. So in Dynamo, you can set a column up and have it be the TTL value. And Dynamo will actually start deleting records automatically once that TTL value has expired. And so in this case, the software, all it's doing is adding rows and updating them at will. And as we see instances die off, those session state table or rows are just going to fall off automatically. So we're using Dynamo just as a leverage tool to be able to make fast queries as well as clean up the data by itself. So if we had a session table look like this, we have an identifier, which in our case is going to be the instance ID. It's that globally unique identifier for a server within Amazon. We're going to have the source IP for the call that we made. We're going to lock on the ARN, which is the key that was minted for that instance. And then the TTL value, which we're going to create with a 6 or 8 hour window, however long you want to keep the data around. But ultimately, you just want this table to be as lean as possible. And the end result of this table will be every session token crafted in your environment that's valid. So if we were to build this manually, we'd go in here and we'd see that the user identity was an AWS service called the EC2 service. And if you remember the flowchart, the first thing we want to look for is the assume role call by the EC2 service. So you're going to see that the service type in the user identity was EC2, but they're also going to fill out the source IP address as ec2.amazonaws.com. From here, if we look in the request parameters, this is the data that we're really interested in. The session name is going to be that instance ID, in this case ending in 2131, and we're going to see the actual role that they're issuing that credential off of. The role in this case is called myCoolRole. In the response elements, you're going to see the session token returned and a bunch of other information, but in this case, we have what we need to fill out that first row. So if we were to add this data into the session table, we have our instance ID 2131 of myCoolRole, and we created a TTL value to start off with. So we're going to continue processing this as we go on. When that token actually becomes invalid and the EC2 service refreshes that for us, the identifier is going to be the exact same. You're going to have the same 2131 instance ID, and in that case, all you're going to do is update the TTL value in your session table to say, hey, this instance is still alive and we want to keep this record available. So now we have the first instance of a session token, but we haven't actually locked it to an IP address yet. So we'll go through here and we say the user identity is type assume role. So that's triggering us that it's a session token, a temporary credential actually making the call. The ARN in this case is the assumed role, my cool role. And as you see, at the end of this ARN is the actual session that the EC2 had put in on that assume role call. So we know this is being made from 2131 instance ID. In that case, we could go down and see what call did they actually make. We can see that it was an EC2 call with an event name of describe instances in region US West 2, but most importantly, we now have a source IP address of 52.95.255.121. And so this is the first time that we've seen a call from this temporary unique credential. And so we're going to go into this table and say, do we have something already, do we have a row for this instance? If we do, then we're just going to update this row. And this becomes our lock IP. So from now on, anytime that we see this session credential being used, we can compare it to that source IP and determine whether it's being used in our environment or not. And most importantly, is it being used on the server that it was minted on, or in the worst case scenario, within the same internal subnet that it was minted from, knowing that all internal subnet source IPs will be the NAT gateway that we have in our environment. So let's continue to process a little more. We see here again, we have a user identity type of assumed role. The ARN is my cool role once again with the instance ID of 2131. We go down here and see it's a describe volumes call this time, and the source IP is 52.95.255.121. If you're really good with numbers, you might already know that we just saw this IP. So when you make the comparison, we know we already have this IP, and so we know this is a good call. We can continue moving forward. So we continue on, and in this case, we have assumed role once again. And as you can guess, it's my cool role for the same instance. We'll move down here and see in the event name, it's actually a call called getCallerIdentity. Now, getCallerIdentity is similar in Linux to who am I. It's going to tell you who the keys are or what key you're actually running with. This might be in a malicious actor's first step in the cloud when they find credentials. It's a good way to determine, is the credential that I've found actually valid, and what potentially could the permissions mean? Other people are actually using getCallerIdentity to do a source of identity trust for initial bootstrapping of other credentials like HashiCorp Vault, but it could be something that you don't see in your environment and you could trigger off of by itself. But in our case, we don't really care what the event is. What we care about is the source IP. And here you can see it's a 67.178.52.232. If you're familiar with AWS, you know this isn't an Amazon IP space. But if we just follow the process that we've talked about, we compare this to the IP that we know about for my cool role of the instance ID 2131, and we know that these aren't the same, so this is where we alert. So this is where I mentioned it might be just a developer that might have pulled credentials down, but potentially it's that malicious actor. But it's enough data that we've gathered that we know it's not operating in our environment, and we should probably go look at it. So we're going to walk through a quick video demo. But essentially, I've launched a sample service, and I'm going to be pulling down the credentials, using them from the instance, my laptop, and then another AWS account of mine, and we'll see how this method actually detects. So here I have a sample service launched in my reInvent account. I've launched it with my role. It has an IP address of 54.209.183.1. I already have an initial table row filled out for this. I have the instance ID that was shown previously. We see that it's my role running, and I have the source IP locked. And so this is just a simple view of the Dynamo table that we have. So now I'll SSH into that instance, and I'm going to create an S3 bucket. The S3 create is actually a call that you will get within S3. So first I'm going to show you that I actually have credentials for this instance. I'm going to run the S3 API create bucket call. I'm going to call it something like good from instance. In this case, I did this for reInvent. So I created a bucket, and we're going to go back to Slack, where we're going to actually have some semi-real-time detection. So here we see that we know that this IP, I'm on the instance where the credential is minted. In this case, I'm actually having my methodology print out whether the call is good or not. So we actually have a view from Otterbot saying this call is great. So now I have a script that I've written that essentially SSH into our instance, curls the metadata service for the credentials that I'm running with, and then exports them into my local environment so that I can use them. So we're going to go ahead and steal the credentials and bring them down to my laptop and try creating a bucket again. So here I've just echoed out the credentials. I'm going to export them later. But here let's create a bucket and see whether or not this can actually be detected. So I'm going to create a bucket called good from lap or bad from laptop, and hopefully this methodology will detect it. If we go back to Otterbot, within seconds we have Otterbot actually showing me that the source IP 69.23.134.92 does not equal the expected IP that we would have seen. And so this is something that AWS GuardDuty can do as well. It won't be necessarily delivered as fast as this, as we're actually using the CloudWatch event CloudTrail stream in this demo. But GuardDuty does a good job of actually telling you that credentials are being used outside of AWS. But if you remember, I copied the credentials earlier. I'm going to show you that on this rogue AWS account of mine, I actually don't have a role on this instance. So the STS get caller identity fails. I don't have actual credentials, so I can't do anything. I'm going to paste in the credentials that I pulled from the instance, run get caller identity again, show that I'm running as the credentials of the first instance that I was on, and then I'm going to try to create an S3 bucket. So this bucket is being created from the rogue instance in a different AWS account, and this methodology will detect that was actually being run as well. And so here you can see two Amazon IPs. One is the expected, the 54.209.183.1, and the call from the rogue instance was from 54.89.102.8. So we've successfully detected credential compromise and a pivot to a different AWS account. And so that's a key differentiator that I was trying to solve when implementing this, is I wanted to actually be able to tell when credentials were being used outside of Netflix's AWS environment and not just AWS in general. So let's switch back and talk about those edge cases. So I mentioned that there are a few edge cases. We talked about the VPC endpoint. So every so often you're making a call that actually goes through an endpoint, and the IP that you're going to see in your CloudTrail is actually a private IP. When Amazon makes calls on your behalf, the IP address you see in source IP address is actually going to be that of an Amazon domain. So if EC2 is doing things on your behalf, you're going to see the source IP of EC2, .amazonaws.com. If they're auto-scaling your server group for you, you're going to see autoscaling.amazonaws.com. So you need to keep in mind that your credential is going to be used from outside of your environment by a trusted AWS. So as long as you trust AWS to use your credential within reason, you can whitelist the Amazon domain and then just continue on if you see that. If you're deploying an instance into an external subnet, the first thing it does is it's going to get a public IP. If it's going to attach a